Time is something we rarely question. It sits quietly in the background of every moment of our lives, ticking forward, never stopping, never hesitating. We treat it as something absolute, reliable, and immovable. Yet, the deeper we look into the universe, the more the illusion begins to crack. Time bends, stretches, slows down, and even seems to dissolve entirely under certain conditions. It behaves less like a universal ruler and more like a flexible shadow, shaped by motion, gravity, and the very structure of space itself. In physics, the idea that time is not constant is not a fringe notion. It is a well-established truth supported by experiments, satellites, particle accelerators, and the very behavior of the cosmos. Our everyday experience is simply too slow, too gentle, to reveal time's true, strange nature. But when we look at the universe through the lens of relativity, or into the world of quantum particles, something astonishing becomes clear. Time is not what we think it is. It is not a river that flows on its own. It is a relationship, a measurement, a shifting phenomenon tied to motion and gravity. And perhaps, in the deepest sense, time might not exist at all. This script is a calm journey through that mystery, a steady walk through a universe where time is elastic, relative, and maybe even an illusion, a construction of consciousness observing change. Each section will peel back another layer, revealing something unexpected, something quiet but profound, something that reminds us how strange reality truly is. Now, let us step gently into the first chapter, Section 1, The Soft Cracks in Reality, How Einstein First Broke Time. To understand time dilation and the idea that time might not be real, we must begin with the moment everything changed. Before Albert Einstein, humanity assumed time flowed identically for everyone, everywhere. Time was the ultimate rule, unbreakable, universal, absolute. But Einstein's insight shattered that comfort forever. What makes this moment so fascinating is how peaceful it was. There was no explosion, no dramatic revelation in a lab. Einstein was a quiet patent clerk, sitting at a small desk in Bern, reading technical documents, and thinking deeply about light. The world around him was slow and ordinary. Yet inside his mind, he was dismantling the universe's most basic assumptions. Einstein asked a simple question that no one else dared to ask. What would the world look like if you could chase a beam of light? That question, gentle and hypothetical, became the seed of one of the greatest scientific revolutions in history. He realized something astonishing. No matter how fast you move, no matter what you do, you can never catch up to light. It always moves at the same speed to all observers, even if they themselves are moving. This is impossible under the old understanding of time and space. So Einstein did something radical. He rewrote the very meaning of time. In his view, time is not independent. It is tied to motion. It is tied to light. It changes depending on where you are and how you move. This was the beginning of the concept of time dilation. The idea that time can stretch or compress depending on conditions. The implications are breathtaking. If you move fast enough, time slows down for you. If you stand near a massive object like a planet or a black hole, time slows down even further. If you move faster or climb higher, time speeds up. Two people standing meters apart can experience time at slightly different rates, not metaphorically, but physically. This is not theory. It is measurable. Every GPS satellite orbiting Earth experiences time slightly faster than we do, because they are farther from Earth's gravitational pull. They must be corrected daily, or your maps would be off by kilometers. That means the smartphone in your pocket silently acknowledges Einstein's dismantling of reality thousands of times per second. But what's even more interesting is the emotional, almost philosophical side of it. If time is different for everyone, if no two people experience the exact same flow of time, then what is time? Is it a thing, or simply a relationship between events? A structure our minds impose on the world? Einstein himself said, "Time is an illusion," not as a poetic metaphor, but as a literal scientific conclusion. He discovered that time is woven into space itself, forming a four-dimensional fabric we call space-time. And this fabric can bend, ripple, and stretch like cloth. Suddenly, time was no longer a ruler, but a shape. It was no longer a straight line, but a flexible dimension. It was no longer universal, but personal. This revelation opened the door to some of the strangest ideas in physics. You can age slower than someone else depending on how you travel. Time can stretch near the speed of light. Time can nearly stop around black holes. Time can differ between mountaintops and valleys. Time may not have a beginning or an end, only a geometry. Einstein took what seemed like a boring, unquestionable background feature of reality and turned it into something alive, dynamic, and deeply mysterious. But perhaps the most poetic realization is this: every person in the universe moves through time at their own unique rate. Every clock ticks differently, depending on its journey. No two beings share the same temporal path. In other words, the universe is not synchronized. There is no universal now. Time unfolds differently for every observer. With Einstein's discovery, time stopped being a rigid box and became a fluid landscape, one that bends around mass, curves with motion, and quietly reveals that our experience of the world is only a small slice of a much stranger reality. Section 1 ends here, a calm beginning in the gentle moment when humanity first discovered that time, the thing we trust most, is not absolute. Section 2. The elastic clock. How motion slowly unwinds time. To truly appreciate the strangeness of time dilation, imagine something simple: a person standing at a train station, watching a sleek, futuristic train pass by at immense speed. The scene feels peaceful: a quiet platform, the soft rush of air, the rhythmic hum of machinery. Yet hidden inside this ordinary moment is one of the most profound distortions in the universe. The two observers are experiencing time differently. This idea sounds fictional, almost mystical, yet it is one of the most rigorously tested truths in modern science. When something moves, anything, whether it's a train, a particle, or a star, time shifts. It loosens, stretches, and softly slows down, like a muscle relaxing under tension. The faster the motion, the deeper the relaxation. To visualize this gently, Imagine time as a ribbon laid out before you. When you walk, the ribbon stretches slightly beneath your footsteps. When you run, it stretches more. And if you could travel near the speed of light, that ribbon would become so stretched, so elongated, that minutes for you might correspond to years for someone else. This is time dilation due to motion, one of the clearest consequences of Einstein's special relativity. But to understand why motion slows time, we need to revisit Einstein's quiet but revolutionary idea. The speed of light is constant for everyone, moving or not. Light always travels at 299,792 kilometers per second, a number so fast it defies intuition. And because the universe protects this speed so fiercely, something else must adjust whenever motion changes. That something is time. Imagine a beam of light bouncing between two mirrors inside a moving train. To someone on the train, the light simply travels up and down, like a tiny glowing ping-pong ball. But to someone on the platform, that same beam traces a diagonal path, longer than the simple up and down motion. Light still has to move the same speed. So to compensate for the longer path seen by the outside observer, time must slow down inside the train so that both perspectives remain consistent. This is not a metaphor. It is an experiment we have repeated countless times. Atomic clocks flown around the world, even on commercial flights, return with measurable differences compared to clocks on the ground. The difference is tiny at airplane speeds, but grows dramatically as velocity increases. When particles are accelerated to near-light speeds in giant machines like CERN's Large Hadron Collider, they live far longer than they should. Particles that naturally decay in a fraction of a microsecond suddenly last hundreds of times longer, simply because they are moving so fast. To them, time itself has slowed. But what makes this phenomenon calming rather than chaotic is that it reveals something gentle about the universe. Time is flexible but consistent. It bends without breaking. It shifts smoothly, like fabric responding to the motion of a hand. This fluidity of time means that the universe is not rigid and mechanical. It is organic, adaptive, and alive with relationships. Time dilation does not create contradictions. Instead, it creates harmony across perspectives, ensuring that every observer, no matter their speed, experiences the laws of physics as internally correct. Motion-based time dilation also opens a doorway into one of the most poetic ideas in physics. The idea that traveling into the future is not only possible, but inevitable the moment you move. You cannot travel backward in time, but you can stretch the path forward. If a spacecraft could travel near the speed of light, the astronauts inside would experience time so slowly compared to Earth that a short journey for them might correspond to centuries passing for those they left behind. This is not science fiction. It is a mathematically precise consequence of relativity, one confirmed through experiment after experiment. This means the future is, in a sense, malleable. Not in the way stories portray, where one can rewrite history or leap impossibly between eras. but in the sense that different beings truly experience the flow of time at different rates depending on how they move. Motion sculpts time. Speed reshapes experience. Every journey is a passage not only through space, but through the structure of time itself. But there is a quieter, more philosophical side to this. If time slows with motion, then what we think of as a second is not universal. It is local. It is personal. A second for you is slightly different from a second for someone on a satellite, or someone in orbit around another planet, or someone deep in the gravitational well of a massive star. Time is not a single melody. It is a symphony of subtly different tempos, all playing together in perfect cosmic harmony. This realization transforms even simple movement into something profound. When you walk, run, drive, or fly, your time shifts ever so slightly. You age minutely slower or faster depending on your path. In daily life, the effect is microscopic, far too small to sense, but it is real, persistent, and measurable. It means that each of us, without noticing, is living inside our own personal clock, one influenced by every movement we make. We are not synchronized with anyone perfectly. We move through time like boats drifting on slightly different currents, always close but never identical. Perhaps the calmest and most astonishing truth in all of this is that the universe is not asking us to understand or feel these distortions. It simply allows them. Time dilation is not a threat, not a punishment, not a glitch. It is a natural result of a universe built on relationships, not absolutes. Motion and time are forever intertwined, partners in a cosmic dance. The faster you move, the more time steps aside and lets you slip gently forward, experiencing the world at a softer, slower rhythm. And in the quiet of that realization lies one of the most beautiful concepts in physics. Time does not simply pass, it responds. Section 3. Gravity's gentle grip. How mass bends the flow of time. If motion can slow time, then gravity can do something even more astonishing. It can stretch time itself simply by existing. Imagine standing in a quiet valley. The air is still, the ground is solid beneath your feet, and nothing appears to be moving. Yet, without any sound or vibration, gravity is tugging softly on the fabric of time around you. The deeper you stand in its invisible well, the slower your time flows compared to someone far above you. This idea feels serene, almost meditative. The notion that time is not a constant drumbeat, but a flowing river whose speed changes gently, depending on where you are in the landscape of gravity. To understand this, picture space and time as a smooth fabric. A massive object like Earth, a star, or a black hole presses into that fabric, creating a curve. Objects nearby feel a pull toward that indentation, which we call gravity. But what we often forget is that time also runs along the same fabric, and when the fabric curves, time curves with it. Einstein's general relativity revealed this with a shockingly simple message. Gravity is not a force pulling you down. It is the bending of time and space around mass. And when time bends, it slows. We do not feel this in everyday life, of course. The difference is subtle. A clock on the ground floor of a building ticks slightly slower than a clock on the roof. GPS satellites orbiting Earth, high above the planet's gravitational grip, tick faster than clocks on Earth. Without correcting for this tiny time dilation, GPS would drift wildly off course within minutes. These differences are small because Earth is relatively small compared to the cosmic giants around us. But the principle remains universal and beautifully simple. The closer you are to mass, the deeper you fall into gravity's valley, and the slower your time moves. This makes gravity not just a physical force, but a cosmic sculptor of time. Each planet, star, moon, and galaxy creates its own unique time signature, a personal rhythm in the grand temporal symphony. Some places beat slower, some faster, but all follow the same majestic rule. Consider the surface of a neutron star, a place where a teaspoon of material weighs billions of tons. Time there would move so slowly compared to Earth that a few minutes on its surface could correspond to hours or even days for someone far away. Imagine standing on such a star, feeling the crushing gravity, and knowing that each second you live is stretched thin, like twilight lingering longer than it should. Then consider the most extreme example, the event horizon of a black hole. Here, gravity bends space and time to such an extreme that time nearly stops at the boundary. If someone watched you fall toward a black hole, they would see you slow down, then freeze, never quite crossing the threshold. Your light would stretch, fade, and eventually vanish, but your last second of motion would appear to last forever. But from your perspective, time would feel normal. You would fall through the event horizon without noticing anything strange. To you, the universe outside would speed up dramatically. Entire epochs might pass in what feels like moments. Stars would drift, galaxies might turn, and cosmic ages could unfold before your eyes as you descended deeper. In this sense, black holes are not just cosmic vacuums. They are temporal gateways, where time behaves in ways that defy intuition, but obey the laws of physics perfectly. Yet the calm beauty of this idea is not limited to extreme environments. Even here on Earth, gravity's influence is quietly sculpting the timeline of our lives. The top of a mountain ages faster than the base. A clock in your head, floating in the microgravity of orbit, runs differently than the one on your wrist. Every part of you, every cell, every thought, every heartbeat is subtly shaped by the gravitational curvature around you. You are living in a slow time bubble created by Earth's mass, drifting gently through a universe where billions of such bubbles overlap and blend. This realization adds depth to simple experiences. Watching a sunset becomes an encounter with physics. Sitting under a tree becomes a moment spent inside Earth's gravitational time field. Even lying in bed at night, you are experiencing time at a pace tuned precisely by your distance from the center of the Earth. Gravity may seem like a force, but time dilation reveals it as something softer, a gradient, a slope, a quiet inclination of space-time that guides motion and regulates time itself. When you understand that gravity slows time, something profound emerges. There is no single, universal now. Your now is slightly different from someone in the International Space Station. Their time runs slightly faster. Your time runs slightly slower. And someone on Jupiter, deeper inside its immense gravitational field, would experience a slower flow still. This means that time is not a single timeline stretching across the universe. It is a vast landscape with hills and valleys, slopes and plains, each region with its own local tempo. We live in a universe of many times, all connected yet distinct. But perhaps the most peaceful aspect of gravity-based time dilation is how natural and effortless it is. You do not need to accelerate. You do not need to travel. You simply exist. And gravity gently shapes your personal timeline. It means that your life is not just a sequence of moments. It is a path through a curved space-time landscape, a quiet journey influenced by the mass of stars, planets, and cosmic structures you will never see. Even now, as you read this, your time is flowing uniquely, affected by Earth, by the Sun, by the Milky Way, and by the great unseen web of gravity stretching across the cosmos. Time is not fixed. It is not rigid. It is soft, responsive, and alive. And gravity is its ever-present companion. Section 4. The gravity that bends time. Imagine standing on a quiet hillside at dawn. The air is still, the sky pale and sleepy, and the world feels almost frozen in a slow, peaceful breath. You wouldn't think that as you stand there, the very flow of time beneath your feet is slightly different than the flow of time for someone at the top of the mountain, or for an astronaut orbiting above the Earth. Yet this is precisely what physics tells us. Gravity bends time, shaping it like soft clay. In this section, we gently unravel how gravity affects time, why clocks tick differently at different altitudes, and why this phenomenon, time dilation, may be one of the clearest signs that what we call time is not a universal river, but a landscape that curves and stretches, a universe that doesn't use clocks. To truly understand gravitational time dilation, we have to start with an uncomfortable truth. The universe doesn't keep time. We do. Our clocks, whether digital, mechanical, or the ancient ones inside our bodies, are all human attempts to measure regularity. But the universe isn't regular. It bends, twists, stretches, and curves according to mass, energy, pressure, and motion. Space isn't a rigid stage, it's a flexible fabric. And since time is woven into that fabric, it bends too. Einstein was the first to show that time is not independent. It's connected to space, forming the four-dimensional structure known as spacetime. And in this structure, mass acts like a weight placed on a mattress, creating a dimple that curves both space and time. Where space curves, objects move differently. Where time curves, events unfold differently. In calm simplicity, gravity slows time down. Einstein's idea that sounded impossible. when Einstein first proposed this idea in 1915. Many scientists found it almost poetic, beautiful, but unbelievable. The idea that time was not the same everywhere felt like saying water wasn't always wet, or that shadows could be touched. But Einstein wasn't imagining. He was calculating. He was predicting. He showed mathematically that the stronger the gravity, the slower time passes. The weaker the gravity, the faster time passes. This means your head ages faster than your feet. A person living on a mountain ages faster than someone living in a valley. Astronauts in orbit age faster than people on Earth. And near extreme gravity, like a black hole, time can slow down so drastically that minutes for one person could be centuries for another. These aren't metaphors. These are measurable, verified facts. The mountain experiment, time differences you can measure. In 2010, a quiet but astonishing experiment was completed. Physicists used two incredibly precise atomic clocks, so accurate they would lose only 1 second in billions of years, and placed one clock just 33 centimeters higher than the other. Just 33 centimeters, the height of a laptop screen, the distance between your knee and the floor, and yet the higher clock ticked faster. The difference was tiny, yes, but real. That small difference proved that gravitational time dilation isn't just something that happens around black holes or in deep space. It's happening every moment, right here on Earth. Every hill, every stair, every step upward changes the flow of time around you, just a little. You are constantly moving through tiny gradients of time without ever noticing. Why gravity slows time? A gentle explanation. The deeper reason gravity affects time is tied to something subtle: energy. To escape a strong gravitational field, you need more energy. Light traveling upward from Earth loses energy. But light cannot slow down, so instead of losing speed, it loses frequency. The color shifts slightly. If light waves can lose energy in a gravitational field, then the waves inside our atomic clocks, the tiny oscillations that define seconds, also lose energy. Less energy, slower oscillations, slower ticking, slower time. Gravity doesn't just pull on objects, it pulls on time itself. The Earth is a time machine made of layers. Think of the Earth like a giant onion of time layers. At the center of Earth, gravity is strongest, time moves slowest. On the surface, gravity is weaker, time moves faster. In orbit, gravity is weaker still, time moves even faster. This is why GPS satellites have clocks that tick about 38 microseconds faster every day than clocks on Earth. Engineers have to manually slow down their onboard clocks so they stay synchronized with ours. If they didn't, your GPS would become wildly inaccurate, off by kilometers within minutes. Your phone's map works because scientists adjust satellites to account for the fact that time moves differently in space. You navigate the world using the bending of time, the quiet, hidden truth of everyday life. All day long, time dilation subtly shapes your life, yet you never feel it. Your heart beats fractionally differently at the top of a tall building. Your phone communicates across layers of time. Airplanes fly in slightly faster time than the ground below. You age unevenly from head to toe. These effects are tiny, yes, but they are always happening. And once you know this, you can never see time the same way again. It stops feeling like a constant march forward and starts feeling like a shifting landscape, a terrain with hills and valleys, where time flows at different speeds depending on where you stand. Time dilation and the illusion of universality. If time can stretch and bend, then it cannot be absolute. There is no cosmic clock that ticks for all beings in all places. There is no shared now between two stars light years apart. There is no universal present moment. Every place has its own time. Every observer carries their own timeline. Every gravitational field shapes its own rhythm. This leads to a beautifully gentle conclusion. Time isn't something we move through. It's something we create locally, wherever we are. The universe does not impose a schedule. We impose it on ourselves. A calm thought before moving on. As you breathe slowly right now, remember, you are not trapped inside time. You are floating inside a field that bends around you. Time is not above you or below you. It is with you, responding to you, shaped by your position in the universe. You are a traveler through a landscape where time flows like soft water, sometimes gently, sometimes strangely, but always relative, always shifting, always unique to where you stand. Section 5. Time at the speed of light, when motion alters reality. Picture a train gliding silently through a moonlit valley. You stand on a hill nearby, watching it pass. From your peaceful vantage point, everything about the train is straightforward. It's moving, its lights flicker across the landscape, and you remain still in the quiet night. But the universe sees something very different. To the cosmos, your experience and the experience of a person sitting inside that moving train belong to two separate realities. And in each reality, time flows at a different speed. This is not imagination. It is the essence of time dilation due to motion. One of the strangest, most elegant predictions of Einstein's special relativity. In this section, we explore how motion itself reshapes time, why clocks slow down at high speeds, and how this phenomenon cracks open the idea that time is something universal or fixed. It's a calm journey into a truth that feels almost impossible. Yet it is one of the most verified scientific facts we have. Why speed changes time. Imagine you are holding a flashlight. When you turn it on, a beam of light bursts forward at the fastest speed allowed in the universe. The speed of light. No matter what you do, run with the flashlight, throw it, jump, ride a rocket. The beam of light always travels at the same speed. It does not add your speed to its own. It refuses to go faster or slower. Light is stubbornly consistent, because nature insists that the speed of light must remain the same for everyone. Something else has to give. That something is time. If you move fast, approaching the speed of light, the universe slows down your time so that the speed of light remains constant for you. It sounds bizarre, but it's a cosmic balancing act. You go faster through space. You must go slower through time. You are still. You go normal speed through time. This relationship is fundamental. Motion through space and motion through time are linked. When one speeds up, the other slows down. The light clock thought experiment. To understand this gently, imagine a simple device. A light beam bouncing between two mirrors, tick-tocking like a cosmic metronome. When the clock is still, the beam bounces straight up and down, a clean, vertical motion. Now imagine the clock on a fast-moving spaceship. To an outside observer, the beam no longer moves vertically. Instead, because the ship is moving forward, the beam travels on a diagonal path, like a tiny lightning bolt zigzagging through time. A diagonal path is longer than a vertical path. But since light must travel the same speed for everyone, something must slow down to compensate. That something is the ticking of the clock. It ticks slower, even though the astronaut inside the ship feels nothing unusual. Anyone watching from outside sees the astronaut's time run more slowly. This isn't a trick, it's geometry, a deeper geometry of the universe. A universe that protects consistency. Motion-induced time dilation is one of the clearest examples of the universe protecting its own rules. Light cannot speed up, so the universe instead bends time to preserve harmony. It's as if reality itself is whispering, to keep everything consistent, your experience of time must slow, so the speed of light stays the same for all observers. This principle has been proven so many times that it has become one of the most reliable pillars of physics. We see it happen in particle accelerators, in high-speed jets, in cosmic rays from space, in GPS satellites, even in atoms moving through laboratories. Time dilation due to speed is not science fiction. It is happening constantly. Every time something travels, even at moderate speeds, the faster you move, the slower your time flows. Muons, the short-lived particles that shouldn't reach Earth. Let's explore a real example that beautifully illustrates how speed bends time. High above Earth, cosmic rays crash into the atmosphere and create tiny particles called muons. Muons have extremely short lifespans. They decay in a fraction of a second. In theory, they shouldn't survive long enough to reach the ground. Even traveling near the speed of light, they should vanish midway. But they do reach Earth. They reach it in huge numbers. Why? Because their internal clocks are slowed by their incredible speed. From their perspective, only a brief moment has passed. But from our perspective, they seem to live much longer than they should. This real-world phenomenon cannot be explained unless time slows down for fast-moving objects. The result is simple and breathtaking. Muons survive because their time runs slower than ours. Time as a personal experience. In the calmest interpretation, motion tells us something profound. Every observer carries their own time with them. There is no shared master clock in the universe. Time is personal, deeply personal. It depends on how you move, where you move, and how fast you travel through space-time. You can imagine time like a fluid flowing around you. If you are still, it moves one way. If you move quickly, it stretches differently.
If you approach the speed of light, it slows almost to a stop. To you, everything feels normal. Your thoughts, your heartbeat, your breathing, all unfold naturally. But to someone else watching you, your entire reality seems to drift in slow motion. It is a beautiful reminder that we experience the world not as it is, but as we move through it. Twin paradox, a calm thought experiment. One of the gentlest ways to understand time dilation is the twin paradox. Two identical twins. One stays on Earth. One travels on a fast-moving spaceship. The traveler moves at speeds close to light, experiencing slowed time. When they return, the twin on Earth is older. This is not magic. It is not imagination. It is physics, smooth, elegant, fully consistent. The twins lived equally real lives, but the geometry of their journeys shaped their time differently. Their bodies followed different paths through the fabric of space-time, and time stretched differently along those paths. In this calm truth, we see something beautiful. Time is not a line. It is a path, and every path has its own length. No one moves through time the same way. Motion-induced time dilation tells us something comforting and strange. There is no universal pace to existence. Two people walking side by side experience subtly different time. Two airplanes flying in opposite directions age differently. Two stars orbiting a galactic center experience completely unique cosmic rhythms. Every object, from a dust grain to a galaxy, travels its own path through space-time, and time flows differently along each path. This is why modern physics treats time not as a global flow, but as a local experience. You have your own time. Your atoms have their own time. Even the photons entering your eyes have their own timeline. We live in a universe of countless overlapping times, a symphony of rhythms, all playing together, never perfectly aligned. A moment of stillness before moving on as you read this quietly. Think of the gentle truth hidden behind motion. You are always drifting through space-time, carving your own personal timeline. Even when you sit still, the Earth carries you. The solar system moves you. The galaxy spins you. You are never truly motionless, and with every subtle motion, your time stretches just a little. Uniquely yours, never quite matching anyone else's. Time is not a command. It is a companion, a flexible, flowing partner that bends and adapts as you journey through the universe.
Section 6. Gravitational time dilation. When gravity bends the flow of time. If motion can slow time, then gravity can reshape it even more deeply. Imagine holding a stretched bed sheet in your hands, smooth, flat, and quiet. Now place a heavy ball in the center. The sheet sags and curves around it. The ball creates a gentle well, a dip in the fabric. Anything that moves close to this well, a marble, a coin, a smaller ball, begins to roll inward or circle around it. This is gravity. But the sheet isn't just space. It is space-time, the connected fabric that contains both where and when events happen. What Einstein discovered is one of the calmest and most profound realizations in all of science. Gravity does not just bend space, It bends time itself. Where gravity is strong, time flows more slowly. Where gravity is weak, time flows more quickly. And the universe quietly follows these rules, shaping everything we see, from the ticking of clocks to the life cycles of stars. In this section, we drift into the soft, strange physics of gravitational time dilation, a realm where even standing on a hilltop places you in a slightly different time than someone below. Time slows as you go deeper into gravity. Let's begin gently. The earth pulls you downward. You feel this force every moment, holding you to the ground, giving you weight. But gravity also shapes the passage of time. The closer you are to a massive object, the deeper you sit in its gravitational well, the slower time moves for you. Standing on a mountain, time is moving a tiny bit faster. Standing at sea level, time is moving just slightly slower. The differences are incredibly small, but they are real and measurable. Atomic clocks placed at different altitudes tick at different speeds. Even the difference between your head and your feet is measurable. Your feet age more slowly than your head because they are closer to Earth's center of gravity. It sounds like a riddle, but it is one of the most elegant truths about our reality. How gravity alters time. To understand the mechanism calmly, picture space-time as a flowing river. Gravity is like placing a large stone in that river. The water, the flow of time, slows as it passes near the obstacle. Why does this happen? Because the fabric of time stretches around mass. Imagine every second around you becomes just slightly longer. To you, nothing feels different. Your heart beats normally. Your thoughts flow naturally. But to someone far from the gravitational source, your seconds appear stretched. Your processes look slower. Your time flows gently, but at a different rhythm than theirs. Gravity is not just a force pulling objects downward. It is a sculptor shaping the tempo of existence. GPS satellites, proof that gravity changes time. Is gravitational time dilation real? Very much so, and our technology depends on it. GPS satellites orbit Earth at high altitude, far from the planet's gravitational pull. Up there, gravity is weaker, so time runs faster. Meanwhile, on Earth's surface, where gravity is stronger, our clocks run slower. If GPS satellites did not compensate for these differences in the flow of time, your navigation system would fail within minutes. Your location would drift by kilometers. Airplanes, ships, smartphones, and emergency systems would all be thrown into chaos. The satellites literally adjust their onboard clocks to account for gravitational time dilation. Every time you check your phone's map, you are using evidence that time flows differently depending on where you are in a gravitational field. The calm depths of a black hole's time. Now let's journey into a more extreme landscape. The realm of black holes. A black hole is gravity taken to its absolute limit. An object so dense, so compressed, that it warps space-time into a bottomless well. Approaching a black hole creates some of the most dramatic time effects in the universe. From far away, an observer would see you slow down. Your movements become sluggish, stretched across seconds, minutes, hours. To them, You approach the event horizon, a point of no return, in slow motion, never quite crossing it. Your signals weaken, your light fades, your time dilates until it nearly freezes. But from your perspective, nothing unusual happens. You drift forward naturally, not noticing the deep slowing of time around you. This quiet contradiction, this peaceful mismatch between perspectives, is one of the strangest features of black holes. It tells us something profound. Every observer lives inside their own experience of time, shaped by gravity's embrace, the center of galaxies, where time crawls. Let's zoom out and imagine entire galaxies. At the center of nearly every galaxy, including our Milky Way, sits a supermassive black hole, millions of times more massive than our Sun. Near this gravitational giant, stars move in graceful orbits, dancing in slow time. Their seconds pass differently compared to stars on the edge of the galaxy, where gravity is weaker. A star deep in the galactic center ages more slowly than one on the outskirts, even if only slightly. Galaxies are not just collections of stars. They are collections of different timelines, woven together like strands in a cosmic tapestry. Gravity sculpts time on a galactic scale, a universe without a universal clock. In this calm picture, the idea of a single universal now disappears. There is no cosmic clock ticking the same seconds everywhere. Instead, time near planets moves differently. Time near stars moves differently. Time near galaxies moves differently. Time near black holes almost stops. Time far out in intergalactic space flows freely and quickly. We live in a universe where time is local, not global. Your time right now is slightly different from the time of someone in orbit, someone underground, or someone flying on an airplane. Time is not a river with a single current. It is a vast ocean, where currents move in countless directions, at countless speeds. Gravity gives time a shape. One of the most peaceful realizations in modern physics is this: gravity gives time its shape. The stronger the gravity, the more curved space-time becomes. The more curved space-time becomes, the slower time flows. It is a perfect, harmonious relationship, a dance between matter and time. Einstein saw this clearly, and it changed our understanding of the universe forever. Mass tells space-time how to curve. Space-time tells matter how to move. And time flows according to the curvature that results. In every direction, the universe adjusts itself quietly to maintain this balance. Your body already lives in multiple times. You experience gravitational time dilation every day without noticing it. The atoms in your feet tick slightly slower than the atoms in your head. When you climb stairs, your body actually ages a tiny bit faster while you are higher. When you fly in a plane, you age a little faster because you are farther from Earth's gravity. These are minuscule differences, measured in nanoseconds, but they are real. Your body is a collection of systems, each experiencing gravity slightly differently. Each part of you lives in its own tiny slice of time, and yet your experience is seamless. Time dilation is not a distant cosmic curiosity. It is woven into your everyday existence. Gravity as a guardian of reality. Finally,
We can think of gravity not only as a force, but as a guardian of consistency. Its effect on time ensures that all events in the universe unfold in a coherent, orderly way. Gravity keeps orbits stable. It keeps stars burning at the right pace. It keeps chemical reactions synchronized. It keeps life unfolding smoothly. Without gravitational time dilation, the universe would lose its harmony. Everything from atoms to galaxies would fall out of sync. Gravity bends time not to distort it, but to preserve the structure of reality itself.
Section 7. Time near the speed of light, when motion becomes a time machine. If gravity can slow time by curving the fabric of space-time, then motion can slow it by stretching that fabric. Together, they create the strange, shimmering landscape of relativity. But on its own, motion produces some of the most mind-bending effects in physics. To understand this, imagine the universe as a giant cosmic river. Every object in this river is drifting forward in time at its own pace. Most of us move through time smoothly, gently, without noticing any difference at all. But the moment we speed up, truly speed up, something begins to change. The river bends around us, the flow of time thickens, seconds stretch, and the faster we go, the slower our time becomes. In this section, we explore how motion reshapes time so dramatically that traveling near the speed of light becomes a kind of time travel. Not science fiction, but a quiet, steady, mathematical reality. The rule that changes everything. Time slows as speed increases. Einstein's special relativity rests on one simple, elegant law. The speed of light is the same for every observer, no matter how fast they move. This sounds small, but it changes everything. To keep this law true, the universe must adjust something else, and what it adjusts is time. If you move quickly, the universe slows your time to compensate, ensuring that the speed of light always remains constant. You don't feel any change, but clocks outside your frame of reference register it immediately. Your heart beats slower, your thoughts slow, your aging slows. To you, life continues normally. But to everyone watching from the outside, you are living in slow motion. This isn't a metaphor. It is a measurable, testable, absolutely real effect. Time dilation on airplanes and high-speed jets. Even at the speeds we experience on Earth, special relativity reveals itself. When atomic clocks were placed on airplanes and flown around the world, they came back ticking differently from the identical clocks that stayed on the ground. The difference was tiny, nanoseconds, but measurable. Astronauts aboard the International Space Station, traveling at over 28,000 kilometers per hour, experience even more slowing of time. Every year, they age slightly less than people on Earth. It's not dramatic, but it's real. Every astronaut who has ever returned home has lived just a little bit in the future. The muon mystery, particles that should not survive. One of the most convincing, beautiful proofs of time dilation comes not from spacecraft or clocks, but from particles in Earth's atmosphere. Muons are subatomic particles created when cosmic rays strike the upper atmosphere. They decay rapidly, so rapidly that by the time they travel the distance to Earth's surface, they should have long disappeared. But they don't. They survive. They reach the ground in vast numbers. Why? Because they are traveling near the speed of light. From our perspective, their internal clocks, their decay processes, slow down. Time dilation gives them more time to live. Even though their natural lifespan is too short to reach Earth, they make it anyway because their time flows differently. From the muon's perspective, its world is compressed. The distance to Earth is shortened by length contraction, another consequence of near light speed, and the particle reaches the ground quickly. Both perspectives are correct. Both are true. Both coexist. Special relativity links them elegantly, without contradiction. Approaching the speed of light, the slow fall of time. As an object gets closer to the speed of light, the effects become profound. At 10% the speed of light, time slows barely noticeably. At 50%, time slows significantly. An hour for the traveler might be an hour and 20 minutes for those outside. At 90%, time slows dramatically. A day for the traveler becomes more than 2 for everyone else. At 99.9%, time nearly freezes. A day for the traveler could be years for the outside world. No matter how much energy you use, no matter how powerful the engine, no matter how far you push, you can never reach the speed of light. But you can approach it. And as you do, time behaves like a soft, stretching surface that yields to your motion. The universe protects its deepest constant, the speed of light, by allowing time itself to change. The twin paradox, a journey into the future. Perhaps the most famous illustration of special relativity is the twin paradox. Two identical twins. One stays on Earth. The other travels into space at near light speed. Upon returning, the traveling twin is younger, not just by seconds, but by years. This is not science fiction. This is mathematics, tested physics, and an unavoidable consequence of how motion bends time. The paradox is only a paradox because our intuition wants time to be absolute. But it isn't. It never was. Time is flexible. Time is personal. Time responds to motion. The traveling twin simply took a different path through space-time, a path in which their clock ticked fewer seconds. Relativity simulator. How your life would change at high speed. Let's imagine a journey. Suppose you board a spacecraft capable of traveling at 99.999% the speed of light. Incredibly fast, but allowed by physics. You leave Earth for a distant star, perhaps 1,000 light years away. To observers on Earth, your journey takes almost exactly 1,000 years. But to you, because your time is deeply slowed, the entire trip might take only a few years. You would arrive in a distant future. Entire civilizations could rise and fall during what you experience as a brief voyage. You would not feel anything unusual. Inside your spacecraft, time would flow normally. Your heartbeats would seem unchanged. Your thoughts would drift calmly. Yet the universe outside would be rushing forward at astonishing speed. Motion becomes a one-way doorway into the future. Why motion slows time? A clear, calm explanation. Here is the simplest and most calming way to understand why motion slows time. Imagine a beam of light bouncing between two mirrors, up and down, up and down. This is how atomic clocks work. Now imagine the clock is moving. From the outside, the beam of light no longer just moves up and down. It moves diagonally, tracing a longer path because the whole clock is in motion. Light always travels at the same speed. So, if the beam has to travel a longer distance between ticks, the ticks must take longer. The clock slows, your heartbeat slows, your metabolism slows, your thoughts slow, your time stretches. This idea, simple as it is, explains everything from muons to spacecraft to the aging of astronauts. High speed as a gateway to the universe. If humanity ever wants to explore beyond our solar system, time dilation may become our greatest ally. It makes long journeys feel short to those aboard. It allows travelers to leap forward in time. It helps future civilizations witness distant eras. It provides a natural, built-in form of time travel. The universe may be vast, but the rules of relativity offer a way to experience it in human timescales, not millions of years, but decades. We will not outrun time, but we can bend it gently with motion. The calm truth: time is not a constant. Motion reveals one of the universe's most soothing and surprising truths. Time is not fixed. Time is not universal. Time depends on how you move. Your timeline is yours and yours alone. A private, personal flow through space-time, influenced by speed, shaped by motion, and protected by the laws of relativity. Where you go, your time goes with you. Everything in the universe, from particles to planets, experiences its own unique timeline. Sometimes they align, often they do not, but all of them are real. Section 8. The Flow of Time. Why our minds create a story the universe doesn't tell. Imagine sitting beside a river at dusk. The water glides past in a continuous stream, carrying leaves, glimmers of fading sunlight, and the soft reflections of clouds overhead. You watch it move, always forward, always in one direction. It feels natural, inevitable, peaceful. For most of us, time feels exactly like that river, flowing from past to present to future. But what if this sensation of flow is something the universe never actually creates, and something only the human mind does? In this section, we step into a gentle but profound idea. Time doesn't flow, you do. And the reason you feel time is passing is not because the universe moves forward, but because your brain stitches moments together into a narrative, like frames of a film, becoming a coherent story. Let's walk quietly through this idea. 1. The universe is a block. Our minds are a movie projector. Modern physics has repeatedly suggested that the universe may be something like a four-dimensional block. 3 dimensions of space, 1 dimension of time. Everything that has ever happened and will ever happen may already exist, laid out in a cosmic geometry. In this view, your birth, your present moment reading this sentence, and your far future all coexist. They are not unfolding. They simply are, like pages of a book already printed. But while the universe might be static, your consciousness is not. Your awareness scans through these pages, creating the illusion of motion. Just like a movie projector takes still frames and animates them, your brain threads static moments into the dynamic experience you call life. You never actually see time flow. You experience your consciousness moving across space-time. This idea is known as the block universe theory, and it's one of the calmest, most dreamlike interpretations in all of physics. 2. The mind's storytelling instinct. Why does your brain insist on experiencing time as a flowing river? Because your mind evolved to predict danger, connect causes to consequences, remember food sources and patterns, synchronize with other humans, function in an ever-changing environment. So your brain builds an inner storyteller, an interpreter, that remembers the past, projects possible futures, anchors you in a now. This storyteller creates the illusion of a timeline, so you can function in a world that feels dynamic and alive. But inside physics, there is no universal now, no cosmic metronome ticking, no absolute present moment. Your brain invented the idea of now, so you wouldn't be lost in chaos. 3. Your sense of time is a reflection, not a property. Think of sound waves. Air molecules vibrate, but sound itself, your experience of it, is a creation of your brain. Sound is a sensation, not an external object. Time is similar. Outside your mind is simply change, the shifting state of particles, fields, and forces. Inside your mind, that change gets converted into the subjective feeling of time passing. Some neuroscientists even argue that time perception is just memory, anticipation, attention. These three ingredients weave a synthetic timeline. Without memory, you'd have no past. Without anticipation, you'd have no future. Without attention, the present would dissolve into a fog. So in a sense, your brain is constantly manufacturing time from psychological components that themselves aren't time. It's like a painter mixing colors that didn't exist until they were blended on the palette. 4. The illusion of flow. Why time seems to move forward. Physics equations are symmetric. They don't care about direction. A particle doesn't know which way time is pointing. Many equations work both forward and backward, but you don't feel time moving backward. Why? Because your brain deeply depends on entropy, the measure of disorder in the universe. Entropy tends to increase, and your neurons evolved in a world shaped by that upward climb. Your memories form in a direction where entropy grows. Your senses process information in a direction where entropy grows. Your consciousness shapes a story in a direction where entropy grows. So you experience that direction, the forward arrow, as flow. The arrow isn't created by the universe. It's created by the mind, reacting to the universe's thermodynamic landscape. A cosmic coincidence, or an intertwined relationship between mind and matter? That's still debated. 5. If time doesn't flow, what is life? Here's where the idea becomes beautifully calming. If every moment exists simultaneously in the block universe, then your childhood still exists. Your future self already exists. Your happiest moments are eternally present. Your lost loved ones are not gone. Their moments still stand in space-time, like preserved rooms in a mansion. Every decision you ever make is one part of a static but infinite structure. Life becomes not a journey through time, but a journey through awareness. Your consciousness is simply a spotlight drifting through the already existing universe, illuminating one moment after another, like walking slowly through a gallery, where each painting is a snapshot of your existence. 6. The calmness of realizing time isn't real. There is something profoundly soothing about recognizing that time's flow is a construction. You are not racing through life. Life is not slipping away. The future isn't coming. The past isn't gone. All moments of your existence are fixed and complete, eternally part of the structure of the universe. You are simply experiencing them in a sequence, like turning the pages of a book whose story has already been written, but whose meaning unfolds only when you read it. This idea transforms fear into curiosity, stress into acceptance, chaos into structure, urgency into presence. 7. The quiet miracle. You are the traveler, not time, in the end. The universe may not be flowing at all, but you, your awareness, your attention, your inner story, move through existence like a gentle wanderer exploring a timeless landscape. And if time is not real in the way we assume, then perhaps what truly matters is not how fast life goes, but how deeply you experience each moment your consciousness touches. Section 9. Time dilation through the lens of consciousness. We have explored how motion and gravity shape the flow of time around us. Now let's look inward. Beyond the physics of clocks and particles, there is a subtler, more intimate layer, how consciousness itself perceives, measures, and even distorts time. Time is often considered an objective dimension, measurable with precision instruments, but your experience of time is not uniform, not mechanical, and not always in sync with the universe's ticks. In fact, consciousness seems to bend and stretch moments, sometimes in ways that echo the cosmic phenomena of time dilation. 1. Subjective time, elastic moments of the mind. Have you ever noticed how time seems to slow during moments of intense focus? Perhaps when staring at a painting, listening to music, or witnessing a sudden emotional event. Conversely, hours can slip away unnoticed during periods of engagement or joy. This is the elasticity of subjective time. While physics measures seconds uniformly, your consciousness introduces variability. Emotional intensity stretches subjective moments. Attention and focus can compress or expand perceived durations. Memory formation affects how long a period feels after the fact. In a sense, the mind functions like a personal time machine, modulating the perceived pace of reality. Much like how moving at high speed stretches or compresses time in relativity, your consciousness experiences its own form of time dilation, the gentle internal echo of the universe's cosmic distortions. 2. Flow states. Time slows to a gentle stream. One of the clearest examples of subjective dilation is the phenomenon of flow, described by psychologist Mihaly Csikszentmihalyi. Flow occurs when your skills and challenges align perfectly, creating complete absorption in an activity. Musicians, athletes, writers, and scientists often report a suspension of ordinary time. During flow, minutes can feel like seconds, hours can feel compressed. Every perception is magnified, yet serene. This mirrors the calm, elegant nature of relativistic time dilation, where motion or gravity slows clocks. The key difference, in consciousness, it is perception that stretches, not the universe's objective clock. And yet, the experience is deeply real, enough to shape memory, creativity, and even life satisfaction. 3. Near-death and peak experiences, time stretched to infinity. People who have faced near-death situations often describe time dilating dramatically. Moments of danger can feel as if they last hours, even though only seconds pass. Similar accounts emerge from extreme adventure, meditation, or intense emotional experiences. The brain, in these conditions, seems to magnify information processing, creating the sensation of slowed time. Neuroscientists propose that these experiences occur because the amygdala, the brain's threat detector, accelerates sensory processing. The hippocampus, responsible for memory, records more detail per second. The subjective present expands to accommodate heightened perception. It is as if consciousness has its own miniature time dilation device, one that activates during life or death scenarios, revealing the elastic quality of perception. 4. Biological clocks and neural oscillations. Our bodies contain intrinsic clocks, circadian rhythms, ultradian cycles, and neural oscillations that organize the flow of consciousness. The rate at which neurons fire subtly influences how we experience time. Faster neural oscillations make time feel slower. Slower oscillations make time feel faster. Drugs, stress, sleep deprivation, and age all alter these oscillations, stretching or compressing subjective time. Even without high-speed travel or extreme gravity, biology introduces its own time dilation, shaping the narrative of each life moment. Your very heartbeat, the rhythm of your breathing, and the pulses of your neurons participate in the subtle bending of perceived time. 5. Memory and the rear-view mirror of time. Another profound way consciousness shapes time is through memory. The past is not a fixed recording. It is reconstructed every time you recall it. Our brains compress familiar routines into a few mental snapshots, while expanding emotionally charged events with greater vividness. This creates a nonlinear experience of time. Childhood summers seem endless in memory. Weeks in adulthood appear to pass in a flash. Moments of crisis expand into detailed landscapes of thought. Memory acts as a second form of time dilation, gently bending how we perceive durations retroactively. The universe itself hasn't changed. Your mind simply interprets events through an intricate, elastic lens. 6. Consciousness as a time navigator. The mind does more than passively perceive. It navigates time. Through anticipation and imagination, humans project consciousness into the future, simulating events before they occur. This foresight allows planning, creativity, and abstract reasoning. Anticipation of danger or opportunity stretches the present. Imagination of future scenarios collapses vast possibilities into single, mentally navigable moments.
Reflection on past choices slows emotional processing. Like a spaceship navigating through relativistic time, consciousness actively modulates its own temporal flow. We are travelers inside the river of space-time, steering our attention to experience moments differently from one another. 7. Mind meets universe. 2 layers of time. Combining physical time dilation with the subjective experience of time creates a dual-layered universe. Cosmic time, dictated by gravity and velocity, measurable with atomic clocks and celestial observation. Conscious time, shaped by neural activity, attention, emotion, and memory. These layers occasionally intersect. Astronauts in orbit experience objective time dilation while also perceiving moments subjectively. Extreme situations amplify both layers simultaneously. Consciousness is a personal time machine, moving independently through the universal river of events, yet tethered by physics. 8. The peace in knowing time is elastic. Here's the subtle, calming realization. If time can bend in both physics and perception, then life's rhythm is flexible, gentle, and forgiving. The pressure of a clock, the weight of deadlines, and the fear of aging dissolve when we recognize that time is not a rigid master, but a pliable companion. Moments can be savored, stretched, or intensified simply by how attention and awareness engage with them. Consciousness allows us to navigate the river of reality at our own pace, giving meaning, serenity, and depth to each moment. 9. A quiet synthesis. In Section 9, we see that motion and gravity warp time externally. Consciousness warps time internally. Both are real. Both are profound. Both coexist in harmony. The universe does not dictate the flow of your awareness. It simply provides the canvas upon which your mind paints the experience of now. Relativity and perception together reveal a universe that is simultaneously vast, precise, and intimately personal. You are both a traveler through space-time and a sculptor of your own temporal experience. Each moment is a gentle folding of the universe's objective timeline into the subjective rhythm of consciousness, and in this realization lies serenity. Time is not lost. It is lived, expanded, and experienced, both by the universe and by the mind that perceives it.
Section 10. Time dilation in extreme gravity, near black holes. In the quiet vastness of the cosmos, there are places where time behaves in ways that challenge not just our imagination, but our very sense of reality. Gravity, the invisible hand that shapes the movement of stars and planets, has a more subtle and profound influence. It warps time itself. Nowhere is this more extreme, more beautifully disorienting than near a black hole. A black hole is not just a collapsed star. It is a point in space where gravity has become so intense that nothing, not even light, can escape its pull. Around it, the very fabric of space-time curves sharply. The closer you get, the slower time flows compared to regions farther away. To an observer safely distant, events near a black hole seem to unfold in slow motion. To someone falling toward the black hole, time appears normal locally, yet everything in the universe outside races ahead. This phenomenon, known as gravitational time dilation, is predicted by Einstein's general theory of relativity. The mathematics is precise, elegant, and, in its consequences, almost unimaginable. Gravity and the stretching of time. The effect of gravity on time can be understood through a simple principle. Clocks run slower in stronger gravitational fields. If you were to place a clock near the surface of a massive object, it would tick more slowly than an identical clock placed far away. Near a black hole, this effect becomes extreme. Seconds for the traveler can stretch into years for an outside observer. Imagine hovering just outside the event horizon of a black hole. From your perspective, the universe beyond would appear to accelerate. Days would pass in minutes. Civilizations could rise and fall, while you experience only a few hours. It is a profound and humbling realization. Time is not universal. Time is a local phenomenon, contingent on your position in the gravitational landscape. This is not mere speculation. Astronomers routinely account for gravitational time dilation in the orbits of satellites around Earth. The clocks on the Global Positioning System satellites tick slightly faster than those on Earth, and engineers must correct for this difference to maintain accurate positioning. On cosmic scales, near black holes, these effects are magnified to extremes that challenge the very nature of reality. Approaching the event horizon. The event horizon marks the point of no return, the boundary beyond which escape is impossible. As one approaches this boundary, time dilation grows without bound. From a distance, you would appear to freeze in motion, suspended at the edge of the black hole, like a single frame captured from a cosmic photograph. Light from your form would stretch, shifting toward the red end of the spectrum, fading as if the universe itself were drawing you gently into stillness. For the traveler, time seems ordinary. Seconds pass, thoughts continue, and awareness flows normally. Yet the outside universe accelerates inexorably. A single hour of subjective experience could correspond to millennia beyond the black hole. To fall into a black hole is to enter a domain where the future of the cosmos stretches ahead in unimaginable rapidity, while your own timeline continues quietly, unaffected in the immediate present. This duality is deeply unsettling and profoundly calming at once. It suggests a universe where reality is not linear, where simultaneity is a relative concept, and where every observer experiences a private stream of time. Black holes and cosmic perspective. Gravitational time dilation offers a unique lens for contemplating the universe and our place within it. While the everyday flow of time feels absolute, near a black hole, time becomes a malleable dimension, reshaped by mass and gravity. It is a reminder that our ordinary experience of seconds and minutes is local, limited to the gentle pull of Earth's gravity. Astronauts in orbit experience minute effects. Near a neutron star or black hole, the effects are dramatic. If one could hover near such an extreme gravitational field safely, they would witness entire galaxies aging in moments, while their own life passed in seconds. This reveals the profound relativity of experience, the multiplicity of temporal perspectives that coexist in the universe. Time as a personal dimension. The lesson of gravitational time dilation is quiet
yet transformative. Time is not a universal river,
flowing uniformly for all.
Instead, it is a personal dimension, intimately linked to position and motion. Near a black hole, time slows to a near halt,
revealing that the universe contains places
where life, thought, and experience are stretched, compressed, or otherwise reshaped in ways that defy ordinary intuition. This awareness invites humility. The cosmos is vast and indifferent, yet precise in its laws. The slow tick of a clock near a black hole
is not a tragedy, nor a catastrophe.
It is a gentle unfolding of nature's rules, a quiet demonstration of the elasticity of reality itself. Time, like space, is not a fixed canvas, but a medium that bends, stretches, and flows differently depending on circumstances. The poetry of relativity. There is a quiet poetry in this understanding. If you were to witness the slow decay of time near a black hole, you would perceive the universe in a state of hyperactivity from your vantage point,
while your own moments remain calm, steady, and coherent.
Time dilation is not a punishment or a limit. It is a window into the universe's true nature, a flexible, intricate, and awe-inspiring tapestry of cause, effect, and perception. Black holes, once feared as cosmic annihilators, become in this view laboratories for contemplating the human experience of time. They show that what we consider absolute is relative, and that each observer carries a private universe,
a unique flow of moments shaped by motion,
gravity, and consciousness. A thought experiment in tranquility. Consider this. If it were possible to hover near a black hole, a single hour of your life could allow you to witness eons passing in the wider cosmos. Civilizations could rise and fall. Stars could live and die. Galaxies could collide and settle into new forms. And yet, you would experience it quietly, without strain, a peaceful observer, adrift in time. This is not just physics, it is a meditation. It reminds us that time is not a tyrant, but a companion, that the universe has a gentle, precise, and deeply expansive structure. Near a black hole, time itself becomes a mirror, reflecting both the scale of the cosmos and the intimate, unhurried rhythm of consciousness. Conclusion. Gravitational time dilation near black holes reveals a truth both humbling and serene. Time is not absolute. It bends, stretches, and reshapes itself in response to gravity. Each observer experiences a personal flow, a private rhythm that may differ profoundly from that of the cosmos around them. In understanding this, we gain perspective, not only on the universe, but on our own lives, our awareness, and our place within the vast, flexible fabric of reality. To witness time dilated near a black hole is to witness the universe's patience, its precision, and its elegance. It is a quiet lesson that every moment we perceive is a gift, a unique thread in the tapestry of existence. And in that reflection, we find a sense of peace. Time may be strange, flexible, and personal, but it is also deeply beautiful.